and Brian from Clayton County. So they just sort of span the whole geographic range of Iowa. And I'm sure there are others here that I'll see during the rest of the time that we're here. But as naturalists and me as a geologist, we're all sort of in the same business. And that's one of translation and interpretation. And we've taken our training in our various disciplines and our experience in the field, and we interpret and translate what we know about the natural world and convey that to public groups, to field trips, to school groups. You know the range of audiences that you have. And my purpose in being here today is to share my particular perspective, which is geology, and try to perhaps add that dimension or that element of the explanation of Iowa's natural world to the places where you come from, so that maybe you find something here that you can take away that applies to your county, to your region of the state, and offers perhaps some explanations for the communities of plants and animals, or the cultural remains, or whatever it is that you're particularly interested in. My purpose is to show you how geology might be at the foundation of those things that you're very familiar with. So I'll take you on a geological tour of the Iowa landscape via some slides and explanations of the geologic history of each of the different parts of Iowa. I want to present this information on a number of different levels that introduce you to a number of different ways of looking at geology in Iowa. And one is to introduce broad chapters that you can really put around parts of Iowa. And the first one is the glacial history of the state. And this has a lot to do with the explanation that you see for the diversity of things across the Iowa landscape. This is just an artist's rendition of the woolly mammoths, and remains of mammoths and mastodons have been found as fossils in all 99 Iowa counties. So this introduction of a glacial scene introduces this concept of the importance of glacial history, which I'll go into in more detail, as one of the foundations of explaining the origins of the Iowa landscape. This is a view of the various glacial advances that have affected Iowa. The Ice Age wasn't just one big period of cold. It was a period of episodes of ice advance coming south and then retreating or melting back to the north, interspersed with periods of warmer climates. So these various glacial episodes during the Quaternary period of geologic time, there were numerous advances of glacial ice over Iowa at different times. As you look at this map, you can see the two most important ones that we have in Iowa. One, the older one, we refer to as the pre-Illinoian, which actually encompasses 7 or 8 different glaciations, which geologists are still trying to sort out. But just keep in mind that over about 3/4 of Iowa, you're looking at glacial age deposits that were left by ice approximately 500,000 years or older. So an area of older glacial materials. Then right in the north central part of the state, you see the Wisconsin, or the most recent glacial advance to affect Iowa, and that's had a very significant impact on one of the regions of the state that we'll look at. As the glaciers melted back, all the different ones from Iowa in the past, leaving the state permanently about 12,500 years ago, since that time, precipitation in the form of rain and snow has been sculpting those deposits that were left behind by the glaciers. So everything that we see now in the landscape is something of glacial origin or older that has been affected by rainfall and snow melt, sculpting and carving those materials. The effect on the landscape then has been to carve it up into the relief or the inequalities of the land surface that you see from one part of the state to the other. And as you look at this map, you can begin to see up here in the northeastern part of the state how rugged that looks, how much relief there is in that area. The north central part of the state, quite a bit flatter. More relief again in the south and off in the west. So it's possible then to draw lines around these different regions. You begin to pick out these regions, and we can actually map them. And using topographic maps, using aerial photos, using some of the new LiDAR imagery, which is incredibly accurate laser measurements that are being done from the air now, accurate within 2 feet or less. So now we name these different regions, and the Paleozoic Plateau, Iowan Surface, the Des Moines Lobes, the Northwest Iowa Plains, the Luss Hills, the Southern Iowa Drift Plain, and the Alluvial Plains. And we're going to look at each one of those regions just briefly to show you how they came to be and how they're different one from the other. That's one of the important things to take away from this, is that there's just this remarkable diversity in Iowa's terrain. It isn't just uniform, boring fields of corn and soybeans. But in Iowa, you have to sort of fine-tune your eye to those differences in landscape appearance, because they are subtle, much more subtle than you would see in the mountain states, for example. But they're there, they're very real, they're mappable, and this is the description or the designation of those regions that we've put together. I'm going to present each of these regions in a certain order to help introduce some of the geologic materials that dominate the landscape throughout the state. So we'll first look at the Des Moines Lobe, that area in north central Iowa that has most recently experienced the presence of glacial ice. So this region of Iowa most clearly shows the direct impact that glaciers had on it in the past. And by in the past, I mean something that happened between about 15,000 years ago, when that lobe of ice began to surge southward from the main continental ice sheet that was across Wisconsin and Minnesota and the Dakotas at this time. This surge of ice came south as far as the city of Des Moines. So that's why it has that name, Des Moines Lobe, and lobe for the shape of it. It has this lobate character. So between 15,000 and about 12,500 was the period of time that ice occupied north central Iowa. And it surged and melted back and resurged. And so there are a series of moraines that cross this area that mark periods of stagnation and then retreat, and then advance and stagnation and retreat. And the effect of that has been to leave a landscape of very poor drainage. That's one of the main characteristics of the Des Moines Lobe, is it's a poorly drained, it's a youthful landscape because the ice has not been gone from the area for that long. Its drainage has simply not had time to get its act together. So it's a very poorly drained area. I mentioned the moraines, the outline of glacial debris that accumulates around an ice front when it's stagnant. Lots of natural lakes are present in this part of the state. This is really the area where you see the most naturally occurring lakes in Iowa. And other wetlands, marshes, bogs, fens are very common in the Des Moines Lobe and are a very important community for wetland, an important wetland, natural wetland habitat in that part of the state. This is an aerial view in Winnebago County, southeast of Rice Lake. And I mentioned the poor drainage, the irregular appearance of the moraine, knob and kettle. Hummocky is another term used to kind of describe this very irregular surface that was last touched by glacial ice. You can see from the color differences in the aerial image, the drier, round, little knobs, the wetter, darker, more moist organic material lying in between them, and not in a very haphazard arrangement, no obvious drainage links in that landscape at all. And then Rice Lake is off there to the northwest. No, we're not advancing. And we're not going back either. To move it when I'm ready to change. So now we'll introduce the first major kind of material. I talked about the glacial deposits. Very often they look like this. The glacial material that glacial ice left behind, for the most part, is very clay-rich with lots of pebbles, different sized pebbles, all mixed together. Just like ice would be able to carry material of all different sizes. It's not sorted at all. It's all mixed together. So this is a good example of what an exposure of more clayey glacial drift or glacial till might look like. Sometimes it's very sandy. The more water that's involved, it sorts the material and you get sand and gravel and silts and clays sort of separated out. But glacial till typically is a clay-rich material. This is a view of another wetland complex. This is in Dickinson County. This is on the Altamont Moraine, one of these arcuate bands of glacial debris that built up around one of the ice fronts. Just showing you the wetland habitats that are very common throughout the Des Moines Lobe region and important ecological niches for waterfowl and other aquatic vegetation and animals that live in these environments. Ocheyedan Mound State Preserve, this is up in Osceola County. This is one of the more prominent knobs of glacial drift that are present in Iowa. These knobs vary in size, but these are called cames, and they're places where there were openings in the stagnant glacial ice where meltwater on the surface of the ice was pouring into a hole and filling it with sand and gravel debris that it was carrying. And you end up with these knobs then of largely of sand and gravel. And this is one of the most prominent and best known in the Iowa landscape in that part of the state. And thus one of Iowa's state preserves. And just the opposite feature on a landscape is the Frieda Hafner Kettle Hole Kettle Hole State Preserve. And this is in Dickinson County. And this is a place where just a big block of glacial ice separated as the ice was melting and retreating, and it just lodged in this area for a long period of time. And once that relatively clean block of ice melted, it just left this depression or kettle hole in the landscape. And this is one of the finest examples of glacial kettles that we have in Iowa. But they are common throughout the Des Moines Lobe. And this one is particularly interesting because of the vegetation that grows on the side slopes, the native prairie that grows here. And drilling has been done in the sediments in the bottom of the kettle hole, and the people who study fossil pollen grains have been able to reconstruct the sequence of the vegetation that's grown in the vicinity of this kettle hole by studying the pollen grains that have accumulated in the bottom of this depression that has no outlet. So you can reconstruct a series of vegetation from pine and spruce into deciduous, eventually into prairie vegetation, and then the plowing or the disturbance that came with the settlement. At the Iowa Great Lakes, Spirit Lake, Okoboji, East and West Okoboji, Storm Lake, Black Hawk Lake. These are all native, natural Iowa lakes that are a result of the glacial activity that was so recently affecting that particular part of the state. West Okoboji is the deepest of Iowa's natural lakes. The next area that we'll take a look at now are the Loess Hills in western Iowa. And this introduces not only a different landscape region that's totally different from the Des Moines Lobe, but it introduces the next dominant geologic deposit to result from the glacial history of Iowa. And as you can see from the map, the Loess Hills are a very narrow, elongated landform region that is directly adjacent to the Missouri River Valley. And this area really shows the effects of wind-deposited loess, which is a side effect of glaciation. I'll show you how that works here in a minute. But the result is a landscape of steep, narrow ridge crests and side slopes, side spurs that go off, features called cat steps, which are horizontal stair-like features across the steeper slopes. Gullies is an important type of erosion that occurs in this very fine-grained, uniform material. And the dry southwest-facing slopes with more moist back slopes has a very significant impact on the ecology in the Loess Hills. This is what they look like from the air. And you can see the sharp contrast between this highly dissected landscape of the Loess Hills on the right and the very flat-lying, cultivated landscape of the Missouri River Valley on the left. And this loess the loess is silt. It's uniform, fine-grained, wind-blown material. And that material came out of the Missouri River Valley during the time that the glaciers were melting. There were enormous amounts of water coursing down the Missouri, the Mississippi, most of the Midwestern interior streams. And during the winter time, when more of the water was locked up in the ice and not so much water out in the floodplain, the winds would sweep that floodplain surface, carry that silt eastward. They were prevailing westerly winds, strong winds, and the coarsest and most abundant and thickest deposits of loess then occur where they were immediately dropped after coming out of the Missouri Valley. So you get your thickest deposits in this part of the state to the point where they directly affect the appearance of the landscape. And then the subsequent erosion of that material by the precipitation that has occurred since is what carved this material up into such intricate, finely dissected landscapes, very different from any other part of Iowa. We have loess over much of the Iowa landscape, but it's so thick out here that it actually accounts for the appearance of the terrain. It actually dominates or constructed its own landform type. This is what it looks like close up. You can see it's a uniform color, a uniform texture. It's thick, and it has a tendency to slab off vertically. It tends to joint or have planes of weakness that extend vertically through it. And once those joints are lubricated by water, that stuff just slumps, and landslides are a particular land use problem out in the western Iowa area, particularly after heavy rains. And it's important then to maintain the natural prairie environments in these landscapes. Attempts to put housing developments or other structures like that too near to the steep slopes is not a good idea. But this shows you what this material looks like and how different it looks from glacial till or glacial drift that you saw in the Des Moines Lobe. There's no coarse material in here at all. Any stones you would find in there found their way there because somebody brought them.
got it.
Yep.
Can you show us it on the edge?
This is an area in Monona County, just giving you a little different view of this intricate topography. We would call this a well-dissected, well-drained landscape. There are rills and little valleys everywhere. And you can see the narrow ridge crests and the steep side slopes, and much of the native prairie that remains in any contiguous pattern is found out in the Loess Hills. These are simply too steep to be farmed for the most part, except in the flatter areas. And you can also see with the absence of fire in this landscape that the timber vegetation has really taken hold on the moist back slopes of the Loess Hills. And this is an ongoing problem for people that are managing prairie in that area. The cedars especially being a problem. Early views of this landscape from the early explorers that came up the Missouri Valley just show this area as being totally devoid of trees, just a true prairie environment adjacent to the floodplain of the Missouri. Now we'll look at probably the largest of Iowa's landform regions, the southern Iowa Drift Plain. And this is different yet from the Des Moines Lobe or the Loess Hills, but it's composed of both of those materials. In other words, we're looking at a landscape of older glacial drift. Those pre-Illinoisan glacial deposits make up most of the landscape material, and then overlying that is a certain amount of wind-blown silt. Not enough to make it look like the Loess Hills, but enough to affect the topography somewhat. So this is a landscape that, because the glacial till is so much older than the Des Moines Lobe tills, that any remaining landscape features that resulted from glaciation have been removed by erosion. There are no more moraines, no more knobs, no more kettles, no more wetlands. It's a beautifully drained landscape. And the effect then is one of steeply rolling hill forms and accordant summits. And by that I mean, if you drive along in southern Iowa and you come up out of a valley and you come up to the top and you look across, everything's going to be at a pretty uniform elevation. You continually come up to that same point of elevation. And that marks the old plain of glacial drift that was once there. So the streams then have carved those glacial materials into a very steeply rolling landscape. It's very effective drainage. All of the landscape, virtually all of the landscape, drains to some waterway of some type. This is a nice aerial view of a typical southern Iowa drift plain landscape. This is in Madison County, not too far from Pamel State Park, and you can just see what is a nice, steeply rolling, well-drained terrain we have there. We're looking at a Loess mantle on most of that landscape, with virtually all the rest of the material down to the lowest point probably being composed of glacial drift, maybe a few exposures of bedrock in the deeper valleys. And you can also pick out the farm ponds. Southern Iowa Drift Plain is where you see a lot of reservoirs, artificial impoundments of various kinds, because the topography is such that you can dam up a stream and hold the water on the landscape. It's not going to go anywhere. So a very nice view of the rills and rivulets and streams draining all the time into a larger and larger waterway and eventually into one of Iowa's major rivers. Just another view. I believe this is in Johnson County, but from the ground view, this probably looks familiar to a lot of you that work in the southern Iowa Drift Plain County. Nicely rolling terrain, few areas of level topography at all. Sometimes on the upland, sometimes down on a valley flat, but most of the land surface is in slope. The next landform region is the Iowan surface. And this one and the next one, which are the Northwest Iowa Plains, are two of a kind. And you'll notice, we're not to the Northwest Iowa Plains yet, but they're that region on the other side of the Des Moines Lobe, west of the Des Moines Lobe. And these two regions have a lot in common. And it's a very open landscape, gentle slopes, gentle inclines, shallow valleys, and this area most clearly shows the effect of what we call periglacial erosion on old glacial plains. In other words, it's the southern Iowa drift plain that's eroded even more extensively to the point where it's taken some of the inequalities out of the land surface and just leveled things out. And this leveling out or erosional scouring took place during the period of maximum glacial cold during the Wisconsin ice period. This ice was not in Iowa at that time, but it was not far away, and it was having a very pronounced effect on the climate to the point where there was a lot of slope erosion, a lot of mass wasting, we call it, where permafrost in the ground would melt for a while, and you would just get, things just got leveled out. So this region of the Iowan surface, it's a complicated history to kind of grasp, but this region and the Northwest Iowa Plains once looked like the southern Iowa drift plain. The sequence of glacial of loess and glacial till is the same. Tree-Illinois tills, Wisconsin age wind-blown silts, and then this scouring out of the landscape to really lower it to a very gentle terrain. When you're in the southern Iowa drift plain, you drop down in a valley and you're out of sight of everything else until you come up again. When you're out on this landscape, you can see for long distances off in different directions. Your view of the surroundings isn't obscured very much. There's a feature here called a paha, and I don't have a picture of one of those, but this may be a term that you've heard applied to parts of the Iowan surface. And these are remnants of this southern Iowa drift plain that are still, they're like erosional remnants. They're pieces of high ground that have been left there by the scouring and erosion that have gone on around it. And that's where you see most of the loess still remaining on that landscape. It's uneroded. And again, a good example of a paha, we came over this morning in Mount Vernon, where Cornell College is. That's probably one of the most obvious examples of one of these long northwest-south trending, northwest-southeast trending lenticular ridges that occur on the southern part of the Iowan surface. Okay, this is, I put this in just to show you that it is possible to map that boundary between the Iowan erosion surface, which is on the left, and the southern Iowa drift plain, which is on the right. One of the good places to see this is in Benton County, and this isn't too far from Blairstown. But you can see the steeply rolling landscapes of the southern Iowa drift plain on the right, and how different that relief is, how much more subdued that relief is on the Iowan erosion surface. We were talking about erratics at lunch, not strange people, but strange dogs. The Iowan surface is a good place to see the results of this scouring in the form of large cobbles and boulders that are now exposed at the land surface because the scouring has removed most of the fine-grained material that was once around it, which is typical of glacial till. So in pastures, often now piled up at fence corners where farmers have removed them from their fields over many, many years, you'll see these piles of stones, or if it's a pasture, the glacial cobbles will still be scattered about just as they originally occurred within the glacial till that was left behind. And these glacial boulders are called erratics because they're not native to Iowa. This is not one of our native bedrock. We have sedimentary bedrock in Iowa for the most part, which we'll talk about here in a minute. But these rocks are igneous and metamorphic rocks that can be traced back to outcrops in Minnesota, Michigan, Wisconsin, and some from northern Iowa too, and northwest. But a lot of these come from just north of here. And as you look at some of these and you pick them up and turn them over and look at them, you can see how weathered they are. Sometimes you'll see a surface that's striated or actually been gouged or grooved out by the action of the ice, moving it around, turning it over, scraping it on the bedrock underneath. They have angles and beveled edges, and glacial erratics are really very interesting stones and have a very interesting story to tell about they're here because of the glacial transport into Iowa from outside of our state. We'll just look quickly here at the northwest Iowa plains. We're looking again at a subdued landscape, broad slopes, and this, as the Iowan surface I mentioned, most clearly shows the effect of this periglacial or near ice front intense erosion that took place eroding these older pre-Illinoisan glacial deposits. In the northwest Iowa Plains area, there's more, you're closer to the sources of the loess there along the Missouri River and the Big Sioux River. So you do get some added thickness of loess that tends to give that landscape a little different appearance than what you see in northeastern Iowa. You don't see as many erratics out there as you do, say, in Black Hawk, Bremer, Chickasaw, the counties over in this part of Iowa. The northwest Iowa Plains, this is just a typical view, long inclines, open views. It's good to point out that when you're in the northwest Iowa area, you're actually, from an elevation standpoint, in the highest part of Iowa. The elevations are gradually increasing in Iowa from east to west toward the high plains of the Dakotas. So you're gaining elevation. So that tends to give a little different look to the land, and it's also drier. If you look at a moisture gradient map of Iowa, the greatest amount of rainfall is in southeastern Iowa, and it's diminishing all the time as you go to the northwest by about 10 inches a year, typically. So you're looking at a landscape that's higher and drier and begins to take on the look of the high plains of the Dakotas. This is just another view of the northwest Iowa Plains. Again, I think this is in Plymouth County, just showing those, again, those open views to the horizon, typical of what you see in the Iowan surface in the northwest Iowa Plains. There's one point that I should have brought to your attention. I'll just do it maybe in this next. we'll just move into the Paleozoic Plateau, because this is where we are now. I wanted to linger in this region. This is the next to the last region. I wanted to linger here just a little bit to show you what's significant about this area where we are here in Dubuque. This is part of the Paleozoic Plateau. And if you could divide Iowa up into just two regions, it would probably be this region and everything else, because everything else has a strong glacial component, whereas this landscape is dominated by the materials that lie beneath those glacial materials. This is a landscape that's dominated by the sedimentary bedrock that occurs everywhere beneath Iowa, but in almost every other part of the state, it's masked by the glacial deposits. They subdue the appearance of the landscape. Those glacial materials are soft, they're relatively easily eroded, they leave a relatively subtle landscape. If those glacial materials are not present, and they are not for the most part in this region of the state, it's a landscape then that takes on a very different appearance, of very bold shapes, steep, angular forms, rock-dominated appearances. This most clearly shows the dominance of bedrock geology and the absence of glacial materials. They once covered this area. The glaciers did cover this area. It's not that they never were here, it's just that the material that they left behind has been removed by erosion. And if you think back to our explanation of the Iowan surface and the northwest Iowa plains, the same thing was going on here in the Paleozoic Plateau. The glacial materials were stripped off of this area. They're gone. And the presence of the Mississippi River so close, that's your base level. That's where everything was draining to. That's one of the most prominent physiographic features of the mid-continent, is the Mississippi River Valley. So a lot was happening in that valley and in the landscapes adjacent to it. So we're looking at a landscape dominated by sedimentary bedrock. That's of the three rock types: igneous, sedimentary, and metamorphic. Sedimentary is what we have here in Iowa, with one exception, but we don't take the time to talk about that. This is a view from the Museum of Natural History in Iowa City, just showing you the environment of deposition in which a lot of Iowa's limestones and dolomites in particular were formed. In other words, we're looking at another component of the state's geology, another piece of the foundation. We looked at glacial till, we looked at loess, now we're looking at bedrock. That's the third of the major building blocks that have assembled Iowa's geologic history as we can see it in the landscape. And Iowa's limestone deposits, which are abundant, dolomite deposits, which are abundant, and which form a lot of the escarpments or cliff faces that we see throughout this Paleozoic Plateau region, they were formed in environments very much like this: warm, shallow, tropical marine environments, in which a lot of animals lived, and those are now preserved as fossil remains in a lot of the limestones and dolomites that you see around the state. So people that are out on field trips in quarries, for example, like to look for the different fossil remains of these. And in the museum, you can go there and actually see what these looked like when they had their soft parts and they were alive and living on the seafloor environment. This is a view along the upper Iowa River, probably between Kendallville and Bluffton. And I put this in because it demonstrates beautifully what these limestone and dolomite bluffs look like close up. And you can, as you look at that, you can see that there's a horizontal pattern, a layering, that is what the sedimentary foundations were as sediments were deposited in these ancient seas, and they accumulated in stacks of sediment. And then as that material hardened, became rock, and the subsequent erosion that I talked about more recently in the glacial history, water has managed to seep down along the vertical planes of weakness through that rock. In other words, as that rock became hard, and then various tectonic forces that were building mountains out west or down in the Ozarks or the Appalachians, as those stresses and strains were put on these mid-continent rock units, they fractured. They didn't move around like a big fault would move them, but they just enough to fracture the rocks into these vertical patterns. And they're oriented along, they're parallel to each other, and they cross at angles. And you can see very clearly how the water has tended to flow downward along these planes of weakness, or these vertical fractures that were present in the rock. And over time, these can be enlarged.
I need something to play with.
There we go. One of the characteristics of a limestone or dolomite, these are carbonate rocks. Limestone is calcium carbonate, dolomite is calcium magnesium carbonate. They're soluble in water. And those rock units are very close to the land surface in the Paleozoic plateau. So what we have going on here is a lot of subterranean drainage. Water, snowmelt, precipitation, infiltrates the land surface and begins to work underneath the ground. The result is karst topography, K-A-R-S-T, which is very common in limestone-dominated terrains. You may have seen a story in the news last week or the week before about a sinkhole in Florida where a whole part of a house and person just disappeared. And Florida is an area of karst topography. The Yucatan Peninsula is a karst topography. Northeastern Iowa, southeast Minnesota, northwest Illinois, southwest Wisconsin, that's all karst. Lots of caves, caverns, springs, sinkholes, disappearing streams. These are all karst features that we see in landscapes that are underlain very shallowly by limestone materials. I have a nice view of some sinkholes in Clayton County. This is an aerial view, and this is a terrain that's underlain at a very shallow depth by these carbonate rocks. And as you look at this, you can see all these little circular depressions. You might think you're on the Des Moines Lobe if you didn't know where you were, because you have these just widely scattered. Some of them have water in them. The sinkholes have been sealed with clay in the bottom, and so they hold water. Sometimes those will flush overnight. Just all of a sudden they'll just drain. Or a sinkhole may open up overnight in a field. And you can see that there are trees in some of them. They are just sort of dimple the landscape surface, and they're very common in the Paleozoic plateau. Got sound effects. Once the water infiltrates those sinkholes and those joints, one of the things that can happen is you get cavern systems developed. And this is a picture of Coldwater Cave in Winnebago County. And this is a time-lapse photograph. This is back in early 70s, I think, late 60s, early 70s, when Coldwater Cave was discovered, and the state began a program to study the cave, and this is one of the geologists who with a miner's light on his hard hat is moving gradually down through the stream. This is a cold water spring or a creek that flows through the cave and comes out as Coldwater Springs State Preserve in Winnebago County. But you can see those crisscrosses in the ceiling of the cave? That's how the water is seeping in. And then as the sides are glistening, as the groundwater that has this calcium carbonate in it then redeposits the lime as speleothems or as stalactites and stalagmites and flow stones and various names for these decorations that occur on the inside of the cave. And then the other major landform feature that results from this karst topography, in addition to caves and sinkholes, are springs. And maybe some of you, while you're here, they'll be going to look at a spring. I think I heard somebody talking about that. This is Dunning Spring, which is coming from the Galena Group dolomite. This is in Winnebago County. And you're just looking, it's kind of hard to pick out, but just right above the waterfall are outcrops, big outcrops, large outcroppings of dolomite, or Division Age dolomite in this case. And that spring is just gushing out of one of the fissures in the rock and tumbling down over the bedrock and into a spring that eventually flows, I think, into the upper Iowa. So sinkholes, caves, springs, these are all characteristic landform features of the northeast Iowa area, which is dominated by bedrock and very picturesque. And Samuel Calvin was one of the early geologists who mapped in this area, and he gave the term Little Switzerland to this part of Iowa for the bold, dramatic landscapes that occur here, that are so very different from anywhere else in the state. This is Bixby State Preserve in Clayton County. Another thing that happens in these landscapes is that cold air seeps down these sinkholes and these fractures, and in the wintertime gravity pulls that cold air down into smaller caves or open spaces in the limestone, and then it's cold. It cools those rocks well below freezing. Then in the summer, the spring and the summer, when it rains and snow melt goes down there, hits those cold rocks, and it freezes. And you get ice formations in those environments that will last into June or July in some cases. And then in the summertime, the air continues its subterranean movement through this karst topography. And in the summertime, you can be walking along, and all of a sudden you feel this refrigerated air coming down the slope. And that forms a wonderful microclimate for unusual plants and animals to grow that typically would be found in much more northern environments than you find here in Iowa. So these are so-called algific slopes, and they occur mostly on north-facing slopes where they don't get the sun, and what you're seeing here is the fog formed from this cold air coming out on a hot July day. And you get plants and animals both that are living on the slopes that are refrigerated and bathed by this cold air. This is where we are now. I really wanted to just spend a minute or two on this. This is a color infrared aerial image that was taken in 1980 from about 40,000 feet. It's color infrared, so things that you would typically see as green or normal colors appear off in this particular photograph. Here, that's Lock and Dam 11, straight up above my finger there. And this is the ice harbor, the harbor area. So we're somewhere right in this part of the photograph here. The photograph there. And this is the Mississippi here. And the Little Maquoketa is coming out there at Peru Bottoms, that delta-shaped thing that's coming into the Mississippi. Well, now take a look at this. See this slice of straight traffic? Central Avenue and is going right up that valley. That used to be, that's called Cooler Valley. It used to be where the Little Maquoketa flowed. In other words, the Little Maquoketa flowed around